Good afternoon, everyone. My name is Jingyi. Together with Booma and Alisha, we're data scientists from Microsoft. So today we're talking about Agentic AI. I know you heard a lot of talk today already, but not the way we usually hear about this talk. So we're not here to sell you about agents at all. We're here to share what we actually learned from building them, including when we choose not to use them at all. So the title says, when and when not to leverage Agentic AI, because in our experience, the most valuable lesson wasn't how to build agents, it was learning when a simpler design was a better choice. Okay, let's go. Here's how we're going to structure today's talk. We're going to start by grounding everyone here on what Agentic AI means, because the term often gets used very loosely. We want to be very precise today. Then we'll walk through 3 case studies from our own work, each at a very different point at the autonomy spectrum. You'll see where agents helped, where they didn't, and where they introduced risks you didn't expect. Finally, we'll close with a very practical evaluation framework, very concrete criteria you will take back and apply to your work tomorrow, and decide whether agent is the right design choice. Let's start by setting the stage. What do we really actually mean by Agentic AI, and why does the distinction matter for how we design the system? So, what makes something very agentic? There are 5 qualities that distinguish agentic systems from the traditional AI and automation. First one is goal-oriented. The system pursues a very objective across different steps, not just one single inference. Then conflict planning. It decomposes a complex task into a sequence of actions, and then it has tools to use. It can call APIs, query database, execute code. It interacts with the environment. Then comes to the memory and state. It revises its approach based on what's learned so far and with autonomy. It operates with reduced human intervention. Now here comes with a contrast on the right hand side. You can see what's the key difference. Traditional AI and automation is input, output. You define the workflow, the AI executes the steps, predictable, repeatable, and transparent. Well, Agentic AI-wise is go, plan, act, observe, and revise. So the AI decides how to achieve the goal. That's very powerful. But it also means the system is making the decisions you didn't explicitly design. That's the important of today's talk. Agentic does not mean better. The question is always, does this task actually need autonomy, or it just need good automation? Let's even push it further, getting more concrete. So this is a side-by-side comparison. Let's walk through each role with me. The first one is execution. Traditional AI approach, it just follow a very fixed sequence. Agentic system plan dynamically and adapt with their goal. Human roles-wise, in traditional design, you architect the entire workflow with agents. You set a goal and guardrail, and the AI figure out the steps. Then it provides a lot of flexibility from the traditional AI perspective. It just handles unknown patterns very well. But the agents will explore normal situations and self-correct. But the flexibility comes at a cost. Predictor-wise, traditional AI will give you the same output every time, but agent varies with the context and state, which means your result might not be reproducible. Debugging-wise, traditional AI is very straightforward. You can inspect every step. Agents are very hard because you don't know how you get the reasoning chain. You can't always see what is made of a particular distinction. From the latency-wise and cost, traditional AI is lower and bounded, but agent-wise is harder and higher and variable because there are multi-step reasoning behind the scene. So what is bad for which situation? The bad for traditional ones is very stable ones, or the stable, repeatable task and auditable task. Agent-wise, it's exploratory and judgment-heavy works. The takeaway here is very simple. Neither is universally better. Choose based on your task risk, observability, complexity, and that's exactly what we will do in the case study. I'll hand it over to you.
All right, so let's zoom out for a moment. We talked about what Agentic AI is and how it compares to traditional approaches. Now I want to show you how this actually plays out in practice as a simple progression from less autonomy to more autonomy. On the left, we start with what most of us are already comfortable with, which is task automation. And this is AI handling the repetitive tasks or well-defined tasks that we all know about. It could be like summarizing metrics, generating dashboards, formatting reports, and whatnot. So basically, it's just reporting what happened. The outputs are very predictable, and if something goes wrong, you'll spot it pretty quickly. And moving towards the middle, it's decision support. So here, AI isn't just reporting. Now things get more interesting because it's analyzing signals and you're proposing actions. For example, think about recommending rollout strategies or investigating some telemetry drops in a metric that you really care about, right? But then here, human is still in the loop. You're reviewing, you're approving. So the AI here, it's just advising, it's not deciding for you yet. Now, we do have the high autonomy end, which is reasoning delegation. This is where AI starts exercising its judgment, right? It's making multi-step decisions on its own, and the outputs require real interpretation, not just thinking about validation. And so the outputs here, get a little bit tricky because the errors become much less visible, and they are also a little bit harder to catch in this case. So the key takeaway here is, as we move from automation to reasoning, the nature of risk keeps changing. So we go from visible errors like things you just catch in a report because something drops, or so, to invisible misjudgments that just accumulate over time. So this is why human oversight isn't just optional in some cases; it is much required. So the real question that we need to ask is not whether to adopt AI at each level. It's whether our governance and oversight model keeps the pace with the autonomy that we are granting to the system that we are building. Right. We just talked about progressing from less autonomy to more autonomy. And what we're seeing here is the same progression, but then it is expanded into some finer grained spectrum from more human control to AI autonomy. And on the far left, you can see human-led. So this maps directly to what we call task automation. The human does the work. AI helps with formatting, retrieval, and maybe providing you with some suggestions, right? This is low risk and very controllable. And then comes AI assistant. Here, AI drafts, but then the humans are still reviewing and we are finalizing. And this is where most teams are today. We will discuss a AI reporting scenario in a minute. And the next one is AI recommended. And this is the decision support zone that we saw in our earlier slide. And here AI isn't just generating content, it's interpreting signals, it's running some analysis, and it's surfacing some recommendations. But then the human still approves and acts. And this is what we will call the sweet spot when we get to discuss case 2, which is about A/B testing analysis. And in the spectrum, the next one you see is AI directed. Now we are entering a reasoning delegation territory. Here AI plans the workflows and decides which steps to take and in what order to take them. And humans can set some guardrails, like setting some boundaries, but then they aren't in the loop for every single move that the agent is going to decide on. So this is a very meaningful jump in trust. And finally, we have AI autonomous, where AI executes end-to-end. Humans define just the intent, okay, this is what I want to build, and then the system acts on its own, it decides on its own. And you will notice we have put cautionary over there because it's high power, but it's also highest risk. Now, moving right on the spectrum is not always progress. It's tempting to think that, more AI, more automation, so more efficiency. But then as autonomy increases, the risk also increases. So it's not just about the capability anymore, it's about failure modes, which brings us to the 3 quick takeaways that we have at the bottom. Simplicity always wins. Deterministic systems, like Jingyi mentioned, they are faster, more predictable, and are easier to debug when you have some issues going on. But agents also introduce hidden costs like latency, debugging complexity, and then there is some inconsistent behavior, especially when you are doing projects at scale. And autonomy only makes sense when you need adaptive reasoning. So think of autonomy as a design choice, not as a default option.
Well, we
talked a lot of concepts right now, and let's move from the concept to practice. We're going to walk through 3 case studies. Each one sits a different point on the autonomy spectrum Booma introduced, and each taught us something very different, where agents earn its place. Let's go through number 1. Code study number 1. This is the simplest one, which is also exactly the point we designed. So we built a weekly report pipeline. Each day, each week, it collects the data from the dashboard for the key metrics, assembles a formatted slide, and then generates the language model commentary on the trend. So the mock report you are seeing right now on the left-hand side is exactly what the output actually looks like. So now, here's a very interesting portion. This is the agentic component, just that component. That component means the language model interprets what actually the metrics means. It reasons about the trends, call out the recovery, flag the guardrail and violation. It's not just formatting for that portion. But how about the entire workflow? That entire workflow is completely deterministic. The stack is fixed, the data source are predefined, the output format is also templated. Everyone follows exactly the same path. This is the design insights. We scope the autonomy to where it adds value. It can interpret the metrics, letting us know, but keep everything else locked down, especially the data quality. The AI reasons about what the data means, but it does not reason what to do next. So the decision stays with the human. When the AI workflow is predetermined, the output is templated, the pipeline is very fast and very reliable, easier to maintain than the agent. So not everything needs to be agentic. Recognizing that is itself a very valuable design decision. On to case study number 2, I'll hand it over to
Thank you. In case 2, we are talking about an A/B testing analysis agent. Now, what does this agent do? If you have ever worked with experimentation at scale, you would know the pain. I hope like some of you are familiar with experimentation and A/B testing. I see some nods. So dozens of experiments, which means multiple scorecards, tons of metrics, and someone manually passing through those metrics, running checks, and interpreting those results. It's rigorous work, but it's also very repetitive, and consistency starts to slip in those cases. And that's exactly what this agent solves. It takes in the experiment stats, it pulls the relevant metrics, and runs the full set of statistical checks like you have SRM, power analysis, and whatnot. And then it surfaces what actually matters, like there's a pattern in retention drop that you want to look up, or there's a change in effect direction, and what are the key insights out of the experiment. And then it packages all of this into a structured, stakeholder-ready summary that you can share out with your business partners. Now here's the critical part. This agent operates within strict guardrails defined by the humans. It cannot ship a variant, it cannot modify traffic allocation, it cannot override a human decision. And human decides and defines the rules. Things like what should be the minimum sample size, or what should be the confidence threshold, what all metrics should I need to look at, and how. So all these things are already defined as guardrails. So the agent doesn't run freely on its own will. It runs within a very controlled framework. And as you can see in the screenshots that we have here, the top one shows the agent bit run, where it is loading the experiment, pulling the metrics, running all the checks that you need, all of them automated. But then the bottom one shows the output, which is a clean, structured recommendation dashboard. If you notice the last line, if it is visible, it says recommendation only, awaiting human approval. That's not a footnote, that's the whole point of it. Because the impact here is very significant. You are reducing manual effort, you're standardizing how these metrics get analyzed and communicated. So, which also enables you can iterate much faster in the cycle, right? And then you can make these insights accessible to both technical as well as non-technical stakeholders. That's a lot of value, and none of it requires the agent to make a single decision on its own. And that's why we call this the sweet spot. High-value automation without delegating the actual decision. And the agent does all the heavy lifting, but the human still makes the call. Right. So now let's talk about why we made the deliberate choice to stop at recommendations and not let the agent actually execute on those decisions, right? So when the agent recommends, it's very low risk because a human still gets to make the call. The reason is very transparent, and you can see why the agent suggested what it actually did. And the decisions are always reversible at this stage because nothing has actually been acted on yet. And most importantly, the accountability still stays with the humans, and you know who owns the outcome. Now, let's say you let the agent execute, things get a bit more serious, right? When the agent acts, errors, they just don't sit in the report. And they can propagate easily into real world outcomes. Say, for example, you let the agent execute and then it ships plan variant B instead of variant A, and then it's not good for your metrics, right? So the cost of being wrong jumps very dramatically. And here's the part that's easy to miss in real world. The metrics the agent is working with, it could be noisy, it could be very ambiguous, like data always is, right? And then there are often hidden confounders that it simply can't see. So you're letting it act on potentially incomplete information, and once that action is taken, you can't undo that action, or it gets difficult to undo that. So that's a fundamentally different risk profile. We can ignore a bad recommendation, but we can't ignore a bad execution, right? And that's exactly why we drew the line back with it. Sharpen that recommendation to preserve interpretability, reversibility, and decision accountability. And those aren't just limitations, they are design choices. And in a system like this, they are lessons. Alisha will now discuss case 3.
Awesome. So for case 3, we move into a more advanced pattern, right? An autonomous investigation agent. Now, unlike the earlier cases where the problem and approach were well defined, here the agent is deciding how to approach the problem itself. Now, the scenario is intentionally realistic. Engagement on feature X drops 15% in 2 weeks. It's a strategic priority, and we ask the agent to investigate using telemetry and recommend next steps. Now, we're not providing the agent which dimensions to explore, what hypotheses to pursue, how to validate, what to conclude. It's super high level. So what makes this agent different is that it's not just answering a question. It's running a full investigation workflow, as you can see here. It detects the anomaly, it segments users, it forms a hypothesis, it validates it against telemetry, and it produces a remediation. And the output feels great. It's structured, it's coherent, and it sounds actionable. Now here's where the story turns. We run the same agent again, same problem, but we get 2 different recommendations. Run A says, disable entry point X. It's attracting low intent users and it's diluting engagement. Whereas run B says, retain entry point X. It's driving discovery and it's removing it will reduce reach. Now both are persuasive and both are very confident. So the practical question isn't, can the agent generate an answer? As you can see, it clearly can. But the question is, what should we trust and why? Now to answer which output we should trust, we just need one more lens. We can't equate confidence with completeness. What the agent gives us is a full executed workflow, but not necessarily a complete view of the problem. It chooses a direction and it builds a coherent explanation around it. It relies on the data it can access and treats that as the full picture. And then it shows what it pursued, but not what it ruled out or never explored. So what we're looking at here is a well-constructed explanation, not the full reasoning space. And that's the subtle risk. A finished analysis can feel like a complete answer. So what do we do with this? In this case, first, we keep the investigation because the exploration is genuinely valuable. The agent can surface patterns and hypotheses faster than a human can. Second, the conclusion requires human judgment. Because the job isn't only to review the output, it's also to ask what the agent didn't test, what it couldn't see, and what alternatives weren't explored. And finally, confidence does not mean correctness. What we saw earlier is that the output can be highly structured, internally consistent, and still be incomplete. So before acting, we validate, we don't assume. So now that we've gone through all the 3 case studies, we'll just go over the decision framework. Now here, after seeing the spectrum of autonomy that Booma showed earlier, the question becomes, how do we decide where a use case should land on that spectrum? That's what this slide is, the GATE framework. I want you to remember this acronym, GATE. It's a practical way to think about the right level of AI autonomy. And we call it GATE intentionally. We call it gate because not every use case should pass through. Grounds is the entry check. Should we even go there? And if we do, the other three determine how far we go on the right of the spectrum. So let's go over each of these. First is grounds. Is this even the right problem for an agent? Is it well defined? Is the data reliable? Does this actually benefit from an agentic approach? If the clarity is low, we stay closer to human control. Next is awareness. Will we know if the system is wrong? And not just eventually, but how quickly and how reliably will we detect it? If detection is weak or delayed, then we reduce autonomy. Then comes tolerance. What happens if it's wrong? As the stakes increase on decisions or customers, the need for human oversight also increases. And finally, exit. Can we recover? If we can't easily roll back or correct the outcome, the autonomy needs to come down. So in practice, ground gets us through the gate, and the rest determine how far we let autonomy go. Because trust isn't binary, and neither is autonomy. I'll pass it over to Booma.
So we just walked through the gate framework, which helps you answer the strategic question, which is, should this even be an agent, or how much autonomy it should have? And this slide kind of makes it practical. So on the left you see, like before you build, which is essentially what Alisha discussed, gate of life, right? And it's about accountability, reversibility, stakes, and whatnot. So it's making sure the problem is actually a good fit before you introduce autonomy. But then where teams often get into trouble is on the right, which is when you deploy. So first, always preserve human override. There should be a clear way to review, clear way to intervene, or override when it's required. And next, start with recommendations and not just actions. Right? This is exactly the lesson that we learned from the A/B testing case that we just discussed. So we let the agent suggest before it executes. It must earn trust before we expand autonomy. And the third one is validating outputs externally. Remember the autonomous investigation case that falls under this one. So don't just trust the agent's reasoning, you need an independent way to verify it. And finally, we have scoping autonomy deliberately. Only added where it clearly outperforms a simpler pipeline. So always remember, if there is high stakes, low reversibility or observability, we should use assistance and not just autonomy. Right, moving on to our final section, let me leave you with 5 key takeaways. First, autonomy must be earned, not just assumed. So don't default to building an agent when you start with something. So rather than asking, can AI do this, think whether we should trust it with this decision or not. Because as we increase autonomy, we are also changing the failure rules. And second, assistance often wins. We saw this in the KR reporting case as well. A structured pipeline with targeted AI was much more reliable, it was faster, and easier to operate and maintain than a fully agentic system. So before reaching for agents, think, do I actually need autonomy here for this use case? And the third one is evaluating decisions, not just tasks. It's not enough that the system runs or completes a workflow. What matters is correctness, stability, and how often humans need to step in to fix things. And the fourth one is boundaries are a design choice. Stopping at recommendation is not a limitation, it's intentional at times. It's how you preserve interpretability, reversibility, accountability, especially when risk increases. And finally, deciding no agent is a valid outcome. In many cases, the simplest system is the most safest and the most effective one. So I'll leave you with this. The real question is not, can AI perform this task? You should be asking, should AI be trusted to make decisions within it? And that brings us to this. Thank you so much for